Olá, pessoal. Seja muito bem-vindo ao nosso Café Consciência. E nosso Café Consciência é uma série de webinários organizada pelos comitês técnicos da Sampe Brasil. A cada 2 semanas, nós trazemos um conteúdo técnico referente às diversas temas, diversas áreas de concentração dos nossos 8 comitês técnicos. E cada webinar traz especialistas numa área específica, um assunto das novidades e do determinado tema do webinar e do comitê técnico que está apresentando. O webinar de hoje foi organizado pelo Comitê Técnico de Sustentabilidade, e eu já mando um super obrigada aí para Camila Castanho, né, que é a líder do nosso Comitê de Sustentabilidade. Eu sou Natália Castro, eu estou aqui hoje para mediar o webinar e para aprender com a Julie Garcia, que é a apresentadora desse webinar de hoje, e vai ser apresentado pela Julie, que é engenheira química e de processo. A Julie trabalha para a Owens há mais de 3 anos como engenheira de pesquisa e desenvolvimento, e ela tem uma importante atuação no setor de energia eólica e de sustentabilidade, com foco principal no desenvolvimento de soluções para reciclagem de vidros e reciclagem das turbinas eólicas. Tem tudo a ver aí com o projeto que ela vai apresentar para nós hoje, que é chamado Projeto Zebra. A Júlia é francesa e vai apresentar em inglês, por isso eu vou fazer a apresentação dela também em inglês. Julie Garcia graduated in Chemical and Process Engineering, has been with Owens over 3 years now as a research and development engineer. She's involved in the wind business and sustainability, mainly developing solutions for glass recycling and repurposing the wind blades, and also managing the Zebra project, which is the main focus of her presentation today. Thank you, Julie, for being here with us, presenting to our webinar series called Café Consciência, Science and Coffee. What a great combination, huh? And exactly. Before I switch over to you, I'm going to present Sampe Brasil to our audience, and the floor will be yours in a few seconds. All right, so, pessoal, Sampe Brasil O que é a Sampe Brasil? É uma associação educacional sem fins lucrativos e fornece novas informações sobre materiais avançados e tecnologias de processo com um diálogo aberto aí com o mercado. Inclui profissionais de várias áreas, dentre elas engenheiros de materiais e processos, engenharia química, qualidade, teste, produção, ferramentais, designers e compras. Tem sede nos Estados Unidos e possui 52 capítulos aí ao redor do mundo. O propósito da Sampe é conectar pessoas e também construir e compartilhar conhecimento para a evolução tecnológica do Brasil. A missão da Sampe é aprimorar a disseminação de conhecimento de materiais avançados e processos tecnológicos envolvidos como foco no desenvolvimento, no setor e no progresso do país. Julie, the floor is yours, and we are excited to hear all about the Zebra project.
Thank you so much. So thank you, everyone. Unfortunately, I don't speak some Portuguese, but thank you for being here today and listen to my project. So I will be talking about the Zebra project, which stands for Zero Waste Blade Research. It's a French consortium that aims to provide a clear solution for future blades by proving fully circular wind turbine blades. I think that I was, well introduced by Natalia, so I will maybe skip this part. Just my prior experience is basically on chemical engineering and process engineering, and I've been in Owens Corning for now 3 years, leading the Zebra project on Owens Corning side, and also providing, sustainable solution for the wind industry. Just to talk about where I work, it's at Owens Corning in Chambéry. It's an S&T center that is specialized also specifically in composite. We have a wind S&T capabilities platform. So We have many capabilities that aims to, provide a technical fabric solution for our customer. There's our prototyping plant in Belgium that allows us to be flexible and, provide solution for customer. And we have also the S&T center in Chambéry that allows us to produce, panels and composite in order to test them very, being very agile, be flexible, and provide data card for our customer. We have a laboratory specialized in mechanical testing that is DNVGL certified, that allows us to provide, show data for our customer, and also, help our customer to build design. We have also pultrusion capabilities in Chambéry that allow us to do glass pultruded specifically for the wind industry. So that's, if you're interested, don't hesitate to reach out after this presentation. So maybe let's jump out now to the Zebra project, which is the core of this presentation, right? So Zebra is zero waste blade research and is a 18.5 million euro project that is both, there's money from the government, the French government, and also from the partners. So this project is about 42 months as a duration of 32 months, and will finish in March 2024. So we are gathering, different kinds of members, so industrial partners as well as, academic partners. In this project, we have huge industries such as Arkema, the resin provider, Engie, the wind farm owner, LM Wind Power, our customer, obviously, and the wind blade manufacturer, and Owens Corning. We are the manufacturer of, of fibers, and Suez, that is displaying a wall of for dismantling the blades. We have also one technical center that is helping us in this project. Everything is managed by the Jules Verne Institute for Technical Research that is managing the project since the beginning. So, to give you some context about this project, it's very clear that today we have a big challenge for the future, especially in the wind industry. We can see that there's an increasing number of installation of wind blade turbines, but for now we do not have any roadmap or clear roadmaps or solution to recycle them or to get rid of them. We will see, in the future, more and more wind blades being discarded and, being, unearthed and going to landfills. There's a big pressure actually in Europe for now because there's a ban plan for 2025 on wind blades to be landfill actually, as well as composite. So composite represent a big part of what is being discarded today because there's no real solution for that as it is based on thermosets. So the solution that we are providing today is, building a blade that cannot be, put to landfill as it has value. It has value because we can recycle every component of it, and it's clearly, circular and recyclable. So for us, we think and we are even sure that this is, the way that is going to grow, recyclable blades. So let's go to the next slide. So we are sure now that providing circular blades that can be recycled is a solution for the future, but it cannot be done without a clear roadmap as well as a clear partnership. So every step of the way, there's a partner that has a key role that will allow us, to close the loop. So let's start maybe from the beginning. So Owens Corning as well as Arkema in this project are, resin supplier and we are fiber supplier, technical fabrics supplier, in order to, develop these blades that actually do not require any change in process for LM Wind Power, as the helium resin that is used in this project is actually very similar to polyester and does not need any change in equipment. So we, as with Helium Wind Power, we also provided a lot of mechanical data in order to create the design of the blades. So in this project, Owens Corning was also a material data engineer in order to help LM and to have this partnership to create the design. So then after the manufacturing, it is exploited for about, let's say, 25 years, but then Suez has the key role of dismantling the blade, shredding it and getting to the depolymerization part. So the key, property of this helium resin is that it can be recycled and it can be reshaped, but it's also recyclable. So being recyclable means that it can also be reintegrated in the production of the blade, in the manufacturing of the blade, and also being reused after many cycles. So for us, this technology will allow us to close the loop. We are also, having the role of, recycler. Sorry. As we are also recovering the fibers after the depolymerization of the composite, we will recover as well as the fiber at the end of life. So that would be, in contact with the resin, but also the manufacturing waste that is happening during the production of the blade. As you know, there's a lot of waste that is generated during the production. So we are also entitled to find, solution to valorize that and also to use that in our processes. So if you have questions, do not hesitate to ask them in the chat, right? So, and we are sure that to make this project a success, we need to have cleverly designed materials. So helium, for example, allows us to do that. As I said, it's infusible liquid thermoplastic that can be depolymerized through pyrolysis. It's also compatible with the thermocell production line, so that allows us to make no modifications. And it's also compatible with our product. So we are also providing solution to optimize, the interaction of the fibers with this new resin. So we have developed a new construction in order for our product to be compatible with this new resin and to keep, same performances. So that's what we did, and that shows very good performances. It shows similar to higher performances to polyester with our product. So that's really a good news. Also, we are, we've tested a lot of products, especially our products with Arkema, to provide a full data card to LM in order to perform the design. So being DNVGL was also really important for us because it kind of sped up the process, basically. So we kept our performances. We got fast by designing this new blade, and we actually produced the first blade in 2022 that is 100% glass based, and it was produced in Spain in Ponferrada. And we are now on our second blade that is going to be produced this year in June. And that's going to be hybrid, carbon, and also glass based, only and still in helium. So for us, that's a big breakthrough, as we managed to produce a blade in a short time and with this new resin system. So we want to go even further, as we want to eco-design this blade. It's to promote recyclability. We are also working on how to automate this process of layering. So that's also a work package we are working on, especially the IRT that is managing the process. It's in order to optimize the manufacturing waste, to optimize also the cycle time, and finally to limit also any kind of default that could happen during the layering. So automating and is also a big part of this, is also a part of this project, and is essential for the future, obviously. For sure, we are not working only on automation, but circularity and proving, how to recycle every part of the blade is essential to prove how circularity. So in this project, so as I said, every partner is responsible for the production, but also for the recycling and the reusing of its own material. So at the very beginning, when the blade is discarded, we are going to collect all the waste, and it's next going through the depolymerization by Arkema. So the aim is to remove the resin with the highest rate, to provide different options for recycling. There's mechanical, because it's it can be reshapable. Thermal, for pyrolysis, it can be depolymerized. Sorry. So it's stripped from the fibers, basically. So that's removing completely the organic content on the surface of the fibers. And it also can be recycled through chemical process that is called solvolysis. These different ways are assessed during the recycling of the blades. So we are not only considering one way to recycle the resin and the fibers, we are considering many ways and assessing then the life cycle analysis, as then we can define, what is the best option of recycling, what has the less impact on the environment, to select the best and most efficient way to recycle this blade. We are also really focusing on the recycling of the fibers. Um, it's it's kind of new project in this way, as recovering fibers is actually mainly not the most field. There's not a lot of literature around that, so this project is actually kind of new on how to process this fiber again to give them some value and reuse them in our process. The main idea is to reuse our fiber and remelt them to produce fibers again and re-enter the loop after the blade would be depolymerized. There's also a possibility to produce secondary raw materials, for example, to reuse the fibers in also some composite application, for example, like extrusion and injection. For the end of this project, we'll aim to have demonstrators to show that. So we'll have a demonstrator to show how to remelt the fibers and to give them another life. And Arkema is also working on another demonstrator for recycling the resin. So we are not only working on the end of life waste, but we are working also at the very beginning of the production. So we are reducing the manufacturing waste, but also finding ways to recycle them also, not only end of life waste. So just some key information about the depolymerization and how are we going to finally process this resin to strip it out from the fiber. So we have two main routes. The first one is dissolution or solvolysis, and the other one is cracking route. So for the first one, we are using MMA, which is the monomer that is used in the helium resin to make the dissolution of the polymer itself. And the cracking route is aiming to increase the temperature of the resin for 300 to 400 degrees in order to start the evaporation of the monomers, and to break it down in order to then strip it from the resin. It's a gaseous process, and then it's condensated to get the monomer that's going to be purified and reprocessed and reformulated for further use. So in the two ways, we are recovering fibers that have some organic content on the surface and that will be able to then reprocess. We have different possibilities for fibers, but you have to know that when the fiber undergo more than 300 or more than 300 degrees, no, I would say 200 degrees, sorry, it's losing actually its performances. So we need to find an application that doesn't need, a high performance at the end. So to finish this presentation, I would say so that This project is actually bringing, a common vision between the different partners. It's have an explicit goals that we are looking at in the same direction. We are building trust between our different partners. We are building also learnings that allow us to create this value chain that we envision. This is really key for the future because value chain ensure that everyone get a value from the product and have a clear a clear solution for its product. So every partner has a real goal and has a clear vision of what he has to do, and we will have normally we have a demonstrator by the end of 2024. So our project execution is also based, on how to, have an open communication and keep our promises because having this blade made shows that we are able to do that, but now we need to recycle it. So just to make a comment about the first blade that we have done in 22. So it's actually being tested for now by LM Wind Power in the facilities in Denmark. They show really good performances for now. It's really positive. And we will now shortly dismantle the blade to go and run through the depolymerization of the blade. So we will start on recycling and at the pilot scale, because we are only working for now on lab scale. In June this year, normally. So thank you very much. And here's how the people working on it, the primarily leader of each company. And thank you very much for listening. Maybe it was a little bit short, but do not hesitate if you have questions. Thank you very much.
Thank you so much, Julie. That was awesome. I appreciate your presentation. And I find here there is a question from our volunteer, Orestes Ferro, who is asking, Dear Julie, do you see any benefit in terms of recyclability of instead of using glass fiber to build the blades, it was used basalt fiber?
So I'm not really familiar with basalt fiber, to be quite honest. But what I can say is that glass fiber is actually recyclable. It can be recycled endlessly, basically. Our main issue, I would say, our main challenge is that we have, some organic content on the surface. So we are managing, ways to remove it. So it's like kind of a pollutant for our furnace. So we are working to clean our fibers, but basically the fact that it's glass fiber does not, impinge in any way the recycling. It's actually endlessly recyclable. So that's just the challenge of recycling the fibers. It's this organic content that stays on the surface, and also, kind of pollutants that you can be in contact with, such as metallic pollutants and, organic content. But I'm sorry, I'm not really familiar with, how to recycle basalt fiber, but I can say that much. I hope it's clear.
That's okay. Thank you so much. Well, we have another question here from Renan De Mori, as another volunteer. Hi, Renan. And he's saying, congratulations, Julie, for your outstanding presentation.
Thank you.
I have a question. Can you tell me more about how do you plan to use recycled glass fibers? What kind of industrial segments?
So within, I would say, for now, we are, we want to prove that it's possible that we can recycle the fibers. We are not, trying to go to industrialization. So we just want to have some proof of concept basically. But I would say that for now, how to recycle fibers, there's two ways mainly. So we are assessing ways to remelt it, so to get some calcine out of it and then to make some fibers again. So that's one of our biggest goal. That's going to show how that we can close the loop. But on the second hand, we are also assessing the repurpose of this fiber. For example, for with manufacturing waste that is still virgin, that is still in pristine condition, we want to use it in different application. I can say, for example, BMC, extrusion, and also why not wood composite. So for us, that's we see two distinction, two main ways of recycling. But
Awesome.
we cannot talk about, I think, industrial segments for now. I would say just proof of concept, just processes for now.
Makes sense. All right. We have another question, and of course, we have a lot of congratulations here on the comments. And Chris Vieira is saying, "Hi, Julie. Thank you." And she has a question. The helium resin has similar properties to polyester?
So indeed, what we can see is that when performing trials, mechanical testing with both polyester and helium, just comparison back to back, we can see that the properties are very similar, and I would say that it's even better with helium in some tests. For example, 90-degree testing, 0-degree tension, sorry, and also fatigue. Fatigue testing is actually kind of better with helium resin, and I think we estimated that to be even 20 to 30% with the same stacking. So yeah, it's even better in some ways, depending on what you are looking for.
Okay, perfect. Sergio Detois is with our group and our director. He's asking a question. Are you and your group interested in joining forces with other companies?
So I would speak for Owens Corning because I think that so we have a contract for the consortium, but at Owens Corning we are really interested in building partnerships for sure. That's something we are still and for forever going to look for. Basically, in our roadmap, sustainability roadmap, we have two pillars. The first one is decarbonization, so to reduce carbon imprint and carbon emission, and also going full circularity. So for us, it's building partnerships, between the composite product manufacturer and the fiber producer. So for us, that's for sure we are assessing partnerships, and we are it's ongoing, I must say.
Okay. So you guys are open for having like other members to your team?
I would say with Owens Corning. So as a company, we are looking for partnerships for sure. Unfortunately for the consortium, it's getting to an end and there's like a limited amount of partners. But for sure, if you are interested in building partnerships with Owens Corning, it's with pleasure that we can talk about it.
Perfect. I have a question regarding the micro plastics and in something around those lines. Do you have anything on your research regarding microplastics being, during the degradation of the blades and things like that?
So we are not looking at this side of the blade. We are not assessing it on the empirical level. However, we are working with NG on the LCA. So that's a really big pillar of this project. Maybe I did not mention it enough, but it's something that we are assessing, the different, the recycling of an helium blade and also the lifetime of an helium blade compared to a polyester one. So we are assessing also the toxicity on the environment, the CO2 emission we are avoiding or we are creating. So I can say in a way we are assessing that, but it's not empirical, I must say.
I gotcha. Well, we have another question from Rafael Regatieri. He's asking about the blade test. What is this test simulating? And he's also asking about a lifetime service.
So it's indeed, mimicking what the blade is going to undergo actually. So you have like compression, tension. I think you have also creep. I'm not sure. It's when the blade undergo like vibration and to assess how it behaves, and you have also for sure fatigue, and that's the longest part of the blade testing basically, because I think over the 8 months of testing it's about I think 3 months, something like that, so it's really long. So fatigue, it helps you assessing how the blade is going to behave after 25 years of service. But for sure,
Mhm.
yes, it's tested. And they were mentioning if they wanted to go to also full failure, but actually we are not. We want to keep the blade pristine and shredding it to assess if there are cracks or anything. So no, it's not for the end of the lifetime, but it's most of its part.
Maybe half lifetime. Because
I think it's the full. I think, yeah, I think so. But if someone from LM is from the team and knows, about this test,
Mhm.
I don't want to, talk for LM.
Would it have like a time that the blade kind of stop having its full performance? Like after a few years, I mean, because we're not, like you're saying, we don't want to just wait for the blades to deteriorate completely and then change them. So are you shooting for a half life type
So
of
for that, I'm really not sure, and I don't want to like give an
still
answer
in
that
progress?
it's in progress. Maybe I
Yeah.
can tell you afterwards, but I'm not sure. But what I know is that there's a lot of cycles of fatigue, and that's I think it's close to the lifetime, but I don't want to give a bad answer about it. So sorry, I really don't know.
No, I understand. Yeah, absolutely. Well, we have another question here is from Leonardo Nade. Congrats, Julie. After the pyrolysis, the glass has any properties losses?
So that's also one of the challenge, because after pyrolysis, it's about, so you undergo a temperature about 300 degrees to 400 degrees, and we observe that the properties of the glass is actually diminishing. So you have a stiffer glass, so it's more stiff in your less flexible, but it's more brittle actually, so it's going to break very easily. And if you want to reuse this glass in other application, mechanical with structural roll, basically it's not going to give you the optimum performances. So yes, the glass is undergoing some losses. It's not the case with solvolysis. So that's also, just a downside of pyrolysis, but it's also more efficient than solvolysis.
Does it gonna take in consideration like the place in the globe that those blades are located? Like in Europe, it's like the temperature is little lower than South America and things like that.
So normally, during the mechanical testing, you also do some mechanical test we at minus 40 degrees, in temperature at 50 degrees or so. So to assess the change in performances of your material. So it shows that the change there's similar change as polyester. So there's nothing that impeach us to put these blades kind of all over the world, I think. So it's what we saw at the composite level. At the blade level, I don't know, but at the composite level, for the design, it's kind of critical, and I think there's nothing that is hampering putting these blades all over the globe, even the low temperature, etc. So
Gotcha.
yeah, that's
Makes
pretty much as polyester.
okay. Gotcha. Well, we have another question. A lot of questions, and that's great. Eduardo Gerhard He says, congrats, Julie. And he has a question. Do recycling strategies in the wind sector already address a design methodology focused on recycling?
So that's really a good question. I think you can see a lot of literature on that on the, on Science Direct, etc., on the different platforms. For now, so do recycling strategies in the so do you mean like there's an eco design, right? That is recommended for yeah. I just reading again because I think I misunderstood it.
That's
So
okay. I'm going to reread it.
Mm, I think that the main, kind of challenge that bring the recycling of a blade is that it's very cohesive. It's like a block basically. So to remove every part, it's very difficult. So if you want, for example, to remove the foam, remove the balsa, you have to basically undergo a shredding step with a sieving step, that allows you to separate. But for now, I do not see any recycling technology that is most recommended because actually, design of blades are not shared with people. It's really something that is not transparent,
Mm-hmm.
and it's something that is then brings you competitive advantage also for some designer. So they're not going to tell you where to get your, I don't know, your H glass or some type of glass, sometimes of foam, etc. So it's really difficult to apply one methodology to every kind of plates. I think for now it's not really well developed, and we should maybe, and there are a lot of people from organization in wind organization that plead to have more transparency on the design, even 25 years later, so they will have it's maybe outdated, and then they can dismantling the blade easily, and by maybe focusing on say certain parts, reusing certain part that can be also structural for to do bridges, for example,
Right.
or like to remove the PET foam that can be also recycled. But for now, no, there's not transparency. The recycling is kind of difficult because you go through shredding. It's kind of really it's a, how can I say, it's a hard process, and that does not allow you to have also clean composite or clean material that produces, I think, also waste.
Mm-hmm.
So for now, I wouldn't say there's like a clear recycling strategy because there's clearly not transparency. So
Mm-hmm.
maybe it will evolve in the future.
Right, right. And maybe this research will generate kind of points during the design phase, maybe
Maybe, yeah.
focusing on the future, kind of
Mm,
forecasting the future. Absolutely, yeah.
exactly. So design for me and design for recycling is the next step, and I think it's not on the recycling part and the recycling actors. It's going to be more on the manufacturers and how they can, maybe provide this kind of information, but not by hampering their own business and own markets.
Right.
So let's see how it goes, but I'm sure it's
Yeah.
it's maybe on the way.
Oh, absolutely. Yeah, we look forward to it. Eduardo has another question. So he's asking, does this need already have an impact on design methodologies conventionally adopted to date, such as international standards or associations, or on the assembly of wind equipment component? Maybe kind of you addressed that already. I mean, want to
Mm,
elaborate a little more about it?
um, so on design methodologies, so
Yeah.
unfortunately, I'm not on the design part of the project. Um, but if maybe on design, maybe in methodologies, maybe we can look. So we've tried in this project also to develop product from even fabrics from recycled material. So this pushed also some of designers to say, okay, what is structural, what has an impact on the mechanical performances of the blade, what does not, and what can be replaced by something that has lower performances, but it's okay because it's not structural. So I think we had maybe that's also producing this kind of thinking, and because lots of manufacturers want to improve also their recycling content, so they are assessing how to put them in their blades. And I think it's also triggering some new methodology of thinking, how to get this recycled content, how to get a new material, but not by not changing so much the design or by not changing their processes. So I think maybe in this way, but I'm sure that provoking, improving, sorry, the recycled content in blades is pushing kind of in this direction. Is maybe to seek out of the box, maybe.
It seems so. Yeah.
Yeah,
That's
I,
great.
I would say so, but
We expect that. Yeah, absolutely. Well, we have Rodrigo Braga also is asking a question. Is there any other recycling project in place that you can share?
So it's not in the wind industry. It's also in Owens Corning. So we are working on a way to recycle our own waste. And I'm particularly working on this project that is called Green Valley. It's not it's not well documented. It's just an internal project, but basically it's how to reduce the waste that we are producing and also finding a new application also for this non-woven waste that we have. And it's also very interesting to see that this project started with European, restriction ongoing on landfill bans, specifically in the northern countries. So that's also another project I can share, is how to recycle non-wovens. That is also an entire different product.
Oh, okay. Is there anything, kind of based in Brazil, for instance, or South America?
That's a good question. For now,
Maybe the audience has that question. They want to know about
maybe.
South America.
So from my understanding, there's some recycling project that we have that is going on in America specifically, especially also in Europe, because you have the pressure also from the EU restrictions that are ongoing, and directives. But I think Europe is looking toward this direction because of these laws that are in place. But I know that we have also some other projects in the EU, in the America, but I don't know about any projects in Brazil.
Okay. All right. We have another question from Rafael Regatieri, and he's asking, any new blade certification is needed for a recyclable blade?
That's a very good question. A new blade certification. That could be maybe a game changer, I think. If you have like this trademark on your blade saying, yeah, it's fully recyclable, then it's also verified by kind of not a lab, but by people that certify it. Um, for now, anyone can call it is blade recyclable until you show that you can really reuse every part of it. So for us, we are considering that it is recyclable because we are showing full circularity. But for now, I don't know if it does exist, and I'm not sure. I'm not sure that there is this kind of certification.
Okay. So you are for having this push that on the certification, having that the blades need to be recyclable? Do you think that that will push more for
Yeah,
recycling them, of course?
I think so, because certification like push you to the very best. I think,
Right.
for example, we have the NVGL, certification that shows that we have best practices and etc. So
Mhm.
I think in the future, if they could be something like that, a certification that tells you, okay, it's recyclable, the LCA is the lowest as possible, it did not travel like I don't know 1,000 miles to get to your to you, or to be discarded. So it wasn't discarded, I don't know, in Thailand or something like that when you get
Mhm.
your composite from here. So to maybe favor the closest processes, the closest loop, actually, and also to ensure the best practices for dismantling, for example. But
Right.
for now, there's no really best method for that. But certification, I think, is something that could be really interesting, and even also at the EU level, that needs a lot of this kind of documents and
Mhm.
certificates and certification. I think that could be really interesting to have that and push forward this kind of initiatives.
They make this type of energy even more sustainable, right? I mean, that will
Yeah.
kind of be impactful to it.
Indeed. Yeah. So
Absolutely.
it's green, it's recyclable, it's also validated by an organism that ensure also like it's something that is clear, and it's there's a transparency about it. I think transparency would be really a key in this kind of initiatives for sure. But
Mhm.
certification, yeah, I think it's a great idea.
Mhm.
Yeah.
Perfect. Would you like to elaborate or kind of address more about your next steps of the research? And
Yeah.
um, that would be
For
great.
for sure. For sure. So we are currently working on the second phase of the project, which is building the second blade, because as I said a little bit, but I think it was not really mentioned. It's We want to have proof of concepts. So by producing these two blades, so the first one was already made in 2022, but working on the second one, we have a new design. Actually, it's a longer design. The first one was 62.2-meter long and about 12 tons. And the second one is going to be 74.4-meter, done in Castellón. It's another plant of LM, with a new design that is incorporating also carbon pultruded. So for us, it's also another step, because we are assessing another design. We are introducing a new material that's also done based on helium. So for us, that's also very exciting to see how it's going to behave, and that's going to be shown in June, if I'm not mistaken.
Okay.
So that's the second phase, but the most important one is showing circularity and showing that we can remelt the fiber and, do again some fibers to, I don't know, for different new application, even fabrics, for example.
Mm,
So recycling is the key for us.
absolutely. Yeah. And about this, the process of recycling, is there, I mean, like different methods that you guys are researching about? I mean, different types of recycling, kind of like not creating a new way um, to need more recycling. I mean, generating more. You have
Yeah,
like different methods for it.
for the recycling, yeah, and we are really targeting the remelting. For us, remelting the fibers, um, it's going to me, it's going to revolutionize. I think the recycling of the fibers. If we are showing the economical and technical feasibility of that, I think we will, prevent a lot of new virgin material to
Mm,
do our glass, to also remove a part of energy consumption, because the glass that at its form is going to need less energy than the classic batch. So basically, remelting for us, it's really the key, and we need just to remove the key technical lock that are removing these organic contents. But after that, and I think by the end of this year, at beginning of 2024, we will have a demonstrator at pilot scale that shows that. So it's basically, making calcine, which is, like little marbles of glass that you can also remelt again to do fibers. So we think we are, and we are confident that we will reach it.
Okay. A little bit about you, Julie. When you started to work with this type of research and work when you joined Owens, or
Mhm.
you were already involved with that before that?
Not at all. So I was doing an internship at Owens Corning, and this opportunity came up, and I was super interested in circularity, sustainability, and to me that was a unique project because I never saw that kind of initiative. I was interested by the subject, but knowing that the blades were not, recyclable, I was, saying to myself, "Wow, that's a big opportunity." So I'm more I'm educated in engineering and chemical engineering, but starting this job was actually more about mechanical engineering as
Mm.
well as recycling. So there's a little bit of process engineering, but material engineering is the core of that project. So that was also a new way of learning a new sector that is material, and it's really interesting. In composite also, it's a whole new world.
Oh, absolutely. Yeah, that's great.
So no, I was not in this project before. I just joined like at the very beginning of the project in 2020.
That's great. That's great. Good. We have another question from Sergio. Julie, are looking after the first, second, and third product life cycles, or your focus is just the first recycling cycle?
Um, For now, we are, I think, on the first cycle. To be honest, for the recycling with remelting, I think you can have as many cycles as you want. So I think we are maybe on the 3 cycles. But regarding the extrusion or regarding also BMC, for example, that are composite that are also made on thermosets that are not recyclable. So we are for now working only on the first cycle, and we know that it's like it can be improved and that we must find also a solution that can also be recycled, but for now we are at the first cycle for sure.
Okay. Well, I any more questions? Let me see. I don't think
I'm really
so.
glad there was a lot of questions. That's
A lot
really
of
really
questions.
nice.
Yes, absolutely. This is a fascinating subject. We
Mm,
really appreciate having you here, Julie. That's really important to have, you know, this insight from the field, straight from the field to us. This is really a privilege for Sampe Brasil to have you joining us.
thank you so much.
Would you like to go through like your final comments before I kind of close up and maybe give them some time? Maybe we'll have like more questions. I don't know. You want to go through your final comments?
I think pretty much said it all, but I would say that there are many ways I think to recycle composites. We did not find the optimum yet, but I think if we keep moving and keep learning and sharing also knowledge, because it's really important, we'll get to a point that we are able to build partnerships and also to recycle in the best way and also with the lowest impact. So to me, building partnerships and sharing learnings, that's I think the key for the future of wind blades, obviously.
That's fascinating about engineering, right? We're always
Yes,
kind of like progressing and inventing new things
mm,
and moving forward.
for
Absolutely.
sure.
That's great. And it's great. It's a privilege to be part of it.
Oh
And
yeah, I can say no, really, it's kind of incredible. And thank you so much for having me. Really,
oh,
it was
thank
super
you for
interesting.
being here today. Absolutely. Well, I'm gonna close up our event today. We have a lot of comments congratulating you, and we are very fortunate to have you here today. And I will speak in Portuguese for the next events that we are gonna have. E, pessoal, muito obrigada por estarem aqui hoje com a gente, participarem desse evento com a Julie, e a gente ter esse privilégio. Obrigada ao Comitê de Sustentabilidade de botar, né, essa apresentação tão interessante para nós, tão atual também. E eu quero convidar vocês para no próximo evento do Café Consciência, vai ser no dia 16 de maio, e o Comitê Técnico de Gestão e Certificação vai estar apresentando aqui para a gente sob a coordenação do voluntário Alexandre Jorge. Então, é isso, pessoal. Muito obrigada. Thank you, Julie. Have a wonderful day, a wonderful week.
Evening.
E obrigada, pessoal. Até a próxima.
Thank you.